Hello everyone, we're back to the e-bike project, and today we're gonna test one of the most fundamental blocks of the bike converted to e-bike, which is the electrical motor. This is 1 kilowatt 80 Newton meter motor that we just bought, and it's gonna be used as a rear wheel motor. Today we're gonna put it on the bike and we're gonna test it with solo. Then we're gonna couple solo with the torque sensor on the crankshaft, and we're gonna see how they work together in analog manner. And then we're gonna talk a little bit about the wiring, some challenges we faced because it wasn't that much easy to put this motor there. In the next projects, we're gonna go deeper, put it on the wheel, and also maybe do a little ride outside. Stay tuned. So now let's check what we have here for the mounting of the motor hub. We have kind of an instruction here. So 2 elements designed especially to be flexible and fix the motor hub, the axle of the motor hub to the frame. So there are set of washers, different thickness to adjust the width of the hub, and 2 nuts. As you can see, the disc brake fit in the caliper. The pads are not touching it so far, but we need to tighten the bolts and check and maybe adjust the caliper also. Here we have adjustment, 2 bolts that we can unscrew and move the caliper so that the pads are not touching the disc during the rotation. So this is the process of this bracket installation with the clamp here and here, probably like that. We will use this clamp. It was in the set of the motor hub from the guys green, and also we will use these washers to adjust this gap. So to fix this bracket using the clamp, I will use the one clamp today, only because today we have only the laboratory test. We also need this bolt and the nut. So as you see, the design is like that. So this is the axis, This is the bracket connected here by the clamp, and I tighten the bolt. So now we can build the laboratory set to test it. This is what I've done with the wires. So the main wires, like using the soldering machine, created these kind of tips. Finally, these are the wires. Main power for the motor. This is the thermistor connection as the shield couple, and this is supposed to be our Hall sensor. As I think, red and black are +5 and G and D, and those are A, B and C. Let's check. Okay, so now I'm gonna define the correct wiring for the Hall sensor and for the motor. Here I will attach the original video from our channel for you to check and learn how it works for other motor. First of all, we need to define the number of poles of the original motor. I already get prepared for that, and the number of poles are 46. Here also I will attach the video from the motor supplier so you can check. First we need to connect to the motion terminal. Okay, coming back to the project. I've actually spent quite a lot of time now because we had a problem here identifying these two wires, the gray one and the yellow one. Somehow the yellow one also has the pulses, but the only 3 wires should have the pulses. So now we already identified the correct wires, and I will show you the process. And here we are connecting now to Solo, getting online, connect. As I already mentioned, the number of poles of the motor is 46. Here we using the Hall sensor and the sensor feedback control mode. We're starting the performance monitor, canceling all the position, the current limit, the velocity, and just checking the angle. So this is profile. You see the correct profile. So here we're rotating clockwise. You see. And here we're rotating counterclockwise. Okay. So for the phase wire connections, I'm going to use this sequence for the first time. I have the table you can find in the original video from our channel. And first I will connect the blue to the A, green to B, and yellow to C. A, B, and C. Okay, so we'll try my guess, and let's see how it works. I will switch on the Solo, so connect it here, getting online. The rest part is already done, so we have the current limit 10 amps, the number of poles already done. Motor identification I need to press once for the connection. Also Hall sensor calibration. Okay. The motor is smoothly rotating. And now we're going to digital torque mode just to try to have a look how it works. So we are going to read the current and velocity of the motor. Let's try to go with 2 amps. So for now we have the voltage limit at 36 and the current limit on the power supply is 6 amps. So 2 should be okay. Let's try. Start performance monitor. We see this plot now. If I apply a little torque on the brake caliper, this is full stop. And we clearly see the velocity is zero when the current is 2 amps. If I release the brake, is getting to the normal speed.
Okay, so I'm gonna add a couple of points to what Andrei just told you guys. So the first point is this: once you are in torque mode, the motor will end up in nominal speed of it. So for instance, if I'm applying 2 amps as the current reference, in this condition my motor goes up to 360 RPM, which this speed depends on the voltage of your supplies, because we are connecting now the motor to 36 volt for this specific test. The nominal speed of the motor is around 360 RPM. If I increase the voltage of supply, I'm gonna have obviously higher speeds, but for this test we don't need it. The second point is about the references. So you see the current is not exactly at 2 amps because now we are testing the motor in no load condition. But as soon as we add any load, like now, I'm adding load by blocking the motor completely, and you can see the current is dead at 2 amps. While I'm applying the brake of the bike, I can increase this to 5 amps. I can feel a little bit of pressure increasing, and you can see here the current went from 2 amps to 5 amps here. And this is the, let's say, the meaning of the torque test, because now in no load condition it's really doesn't make a lot of sense to talk about torque sensing and torque control. But anyways, by blocking the motor you can see how we are actually able to do that. Okay, so out of curiosity now let's test the speed mode, because in a speed mode we're gonna ask the controller to keep the speed at a constant value for us. So the two most important parameters here are the speed controller KP and KI. For now, we've found these two gains that are really working for now acceptable, because now we are not applying a lot of load. So you can see the speed KP is much higher than KI. And now I'm gonna run the monitoring. So we are looking at the velocity, which is at 0, and the torque that is around 0 now. So once I ask the motor to go to, for instance, 100 RPM, you can see here that the motor went to that speed, a little bit of overshoot because of the gains, and we can tune it better. But the speed is very well at 100 RPM. I'm gonna add some torque. I'm gonna ask Andrei to apply some load on the motor. So please slowly increase the brake power. So you can see the blue line is going higher and higher, I mean in a negative value. So we are applying higher and higher amount of torque, but the speed stays constant around 100 RPM. And he can try to keep, yes, he can. Please lock the motor now again. So you can see once he locks the motor with the brake, the speed goes to 0, and we are at 10 amps, which is the current limit value. And then you can see here also the stall detection error appearing because it's activated now in solo. And that's it. This was the whole notion of the speed controlling, but probably we will not use it. We will use only torque controlling.
So now I'm going to connect the torque crankshaft and have a look what we have with the constant brake torque, for example. Okay, we have 5 volts torque and GND. This is the red one, GND. So now we blocked the motor hub, and the idea is to try the crankshaft Yeah, I'm going to show how it works with the torque. So as I already mentioned in the previous video, the torque is measuring like between the spider and the crank. They're inside, the cell is inside. So this is the idea, like because we don't have the wheel, we are not connecting chain. The idea was to implement it like that. So we're blocking the spider and applying the torque to the crank.
Look at this.
This is working, so I'm applying the torque.
It's resisting against
And
the
you
load.
see, it is resisting, yes.
Beautiful. Cool. This is recorded too. Actually, the offset is not that much. It's almost zero.